All right, so day 2, we talked about and reviewed solving. Basically, that is your verb that you're more familiar with. And this is gonna also be very similar to everything else we've been doing in that you're gonna use logs to undo powers and powers to undo logs. So since I see that 28 is a power problem, I'm gonna end up having to use a log to solve it. If your power part is already alone, meaning there's nothing else with it, you rewrite it. So log base 8, the power goes here, the other number goes here, and these we separate for our calculators to solve for us the same way we have been in the past. You take the log of the top number, divide it by the log of the bottom number. I did these on my calculator earlier, so hopefully these answers are all correct. And the important thing to do is remember that you need to close that parenthesis right there. Otherwise, it's going to give you the wrong answer every single time. Also, remember to put a log on the bottom as well. Okay, here I have e to the power. I need the power part alone, so I take away 1. So I'll have e to the x equals 6. Now the power is alone. Time to log it. That would be, and if it's easier for you to take that intermediate step, you can write it as log base e. Power goes over here, other number here. This is, however, just ln. Base e means ln, so I ln 6 on my calculator and get 1.792-ish. Here, the power part is this. I need to get rid of everything else, so I add 6. 4 to the x is 10. I'm sort of stuck with the power. Time to log it. Log 4 is the base, goes in the basement. X is the power, goes over there. 10 goes here. And I split this up to let my calculator solve it for me. So log 10, close that parenthesis, divide by log 4, and I'm getting 1.661. It says round to 3 decimal places, so that's why I'm doing that. Here I have 5 to a power, but it's by itself. There's nothing else added or subtracted. So I go straight to writing it as a log. 5 is the base, 2x is the power, and then 4 is my other number. So I'm going to do log 4 over log 5. And then that turns out to be like 0.861. And then to get the x alone, like we're solving for x, I'm going to divide that in half. And I'm going to get 0.861 divided by 2. I end up at like 0.4305. So I guess that rounds off to 0.431. Here the power part is this, meaning the part that has the power. So that means I need to get rid of the 3. So I'll take it away to the other side. And then I am ready to write it as a log. This is a 10, looks like a 16. So log base 10 doesn't really have to have a 10 written there. The power goes over here, the 16 goes here. Because I don't have to write that as a common log, I literally can just type in log 16. So then this part becomes 1.204. And now I'm just solving for x like algebra 1. So I'm going to add 3 to both sides and then divide by 2. So I'm getting about 2.102. Here, kind of same thinking. Here's my power part. I need to get rid of everything else, so I'll start by getting rid of the 4. And I will now have just a power, so it's time to write it as a log. 7 is the base, 2x minus 3 is the power, 18 is the number. This I get on my calculator by doing that again. And that lands me at about 1.485 on my calculator. And then to solve that, I'll need to add 3. And to get to the very end, I'll divide that in half. So I'm getting 4.485-ish divided by 2, and I get 2.243-ish. Sorry, I'm writing something down. Taking a little break. Okay, so that's solving exponential equations, meaning you start with an exponent, so you're going to use logs. Now we're going to go to solving log equations, which means we're going to end up having to change to power form. And once you change to a power, you're going to be able to use your calculator. Okay, so let's do that. So this is a base e. So I have e to the 4 equals x, and then I just do e to the 4 on my calculator, and I'm ending up with about 54.598. Here I have logs on both sides, so those are actually slick because they cancel. So I get x plus 48 equals 5x, and then I just solve it like regular algebra 1. So I have 48 equals 4x, and I end up with 12. Here I have the log part alone, but I only have one. I can't cancel them, so I rewrite it. 2 to the 8 equals 3x minus 1, but 2 to the 8 is 256. So I'm going to add 1. And then I'll divide that by 3, and I get about 85.333. Here, the log part starts here, which means I need to get rid of the 2. So I divide that out of both sides so that I have log base 5 of all this fun stuff. And that would equal 6 now. And now I have just the log, so it's time to rewrite it, starting with the base, go get the power, come back around. So 5 to the 6th power is this big old number. So I'm going to add 80. And then I'm going to divide that answer by 5. So what do I get? 1, 5, 6, 2, 5 plus 80. So then I'm going to be at 15,705, and that equals 25x. So dividing that by 25, I get an answer of about 628.2. Okay, here is the log part. And then there's a plus 3 that's like extra and tacked on, so that has to go away. So now I have my log part alone, and once the log part's alone, I rewrite it. If I need to, I can write an e there to remind myself that ln's base e. So e to the 4 is 3x plus 9. So I go to my calculator, and I find out what e to the 4th power is, and it's about 54.598. And now I'm just going to algebra 1. I'm going to go ahead and take away 9. Puts me at 45.598, and then I'll divide that by 3, and when I do, I end up with 15.2-ish. Okay, now this has 2 logs, but they are on the same side, so I actually have to put them together by multiplication. So this one's tricky, and this would be an extra credit problem, because you end up with 4 to the 2nd equals x times x plus 6. And the only way to solve that is to distribute the x, get everything to one side since there's a square, and then factor. So I need a way to make 16 that subtracts to be 6. My options are 1 and 16, 2 and 8. That's what I need, because that will make 16 and subtract to be 6. In order to get a plus 6, I'd need a plus 8 minus 2. And in order for each to equal 0, the only way x minus 2 would be 0 is if x was 2. And the only way x plus 8 would be 0 is if x is negative 8. So that one is beyond what you would need to do just for like regular test preparation. Okay, I'm going to stop there, and then I'll make another video for the word problems. Thanks, guys.